All right, so now we're going to take a look at lesson 2. Lesson 2 is equivalent expressions. So we're going to start off with three different properties: the commutative, associative, and then distributive properties. Then we're going to look a little bit at factoring out a greatest common factor, and then finally we will take a look at some of the rules that have to do with exponents. So at the top here it says that certain properties exist for all real numbers. For example, the order in which two numbers are added does not matter. The sum will always be the same. The same is true for the order in which two numbers are multiplied. The product will always be the same. So the first property we want to highlight here is the commutative property of addition. And all this is saying is that if you add two numbers, for example, a plus b, it doesn't matter which order you add them in. So a plus b is still equal to b plus a. The example they gave was 6 plus 3 is equal to 3 plus 6, and they both equal 9. So again, the order didn't matter. And here you could come up with any example that you wanted. We could throw in there, say 100 plus 4 is going to be equal to 4 plus 100, right? Because 100 plus 4 is equal to 104, and 4 plus 100 is still 104. So again, the commutative property of addition is that order does not matter. When we look at multiplication, that holds as well. So the commutative property of multiplication says that a times b is the same as b times a, or for example 5 times 8 is the same as 8 times 5, because they both equal 40. One thing to highlight here is that when we're dealing with the commutative property, there is no commutative property for subtraction or division. So if we take a look here, it does not apply to subtraction or division because order does matter when we're subtracting or dividing. So if we did 6 minus 2, that would not be the same as 2 minus 6 because 4 is not equal to negative 4. So that's our commutative property. The next property we want to take a look at is the associative property of addition. And the associative property of addition just has to do with how we are grouping the numbers. So if you notice, we have parentheses here. If we scroll up a little bit, we have parentheses here at a plus b, and then after we've added those, we would add c. If we move those parentheses and add b plus c first, and then add a, it doesn't change our answer here. And the example they gave was 2 plus 7 plus 1, with the first 2 and 7 in parentheses. So that would equal 9 plus 1. On the other side, we have 2 plus 7 plus 1, but the parentheses is over with the 7 and 1, which gives us 8. And then 2 plus 8 equals 10. 9 plus 1 equals 10. The main thing with associative property is you're just looking for the parentheses here. So here we have our parentheses started there and then moved there. But if you take a look at the actual numbers in here too, those didn't change. So we still have A, B, C, and that continues over here with A, B, C. So the order of numbers did not change, but the grouping of what we work with first does. And this is the same for multiplication. If we take a look at our original set of parentheses, and they just slide down and they're grouped with another set of numbers there. But we still have A, B, and C, A, B, and C. So the order didn't change. If you take a look at this example, they show you that how if you multiply 3 times 4 times 6, or 3 times 4 times 6, multiplying 4 times 6 first versus 3 times 4 first, you'll eventually get to the same answer of 72. However, again, very important is that this does not apply to subtraction or division. So both of these properties, if we take a look there, only work with multiplication or addition. So their example says, what number replaces n to make the equation below true? So if we're looking here, first we want to see, did they move things around and use commutative property? And the answer to that would be no. We say no because we have parentheses here and parentheses here, and that is what they moved. They moved the parentheses, which changed the grouping of what numbers we dealt with first. So here we're dealing with 3 times our mystery number n, while over here we're dealing with 8 times 3 first. So, like we saw up here though, when we have associative property, the parentheses move, but the numbers remain the same. So if we're trying to figure out what number to put in here for n, we can look on our right side of the equation and we can see that the order of numbers was 8 times 3 and then times 12. Well, that 12 still needs to appear on our left side, and it needs to appear in the same spot, which is the third number in. So we'll have 8 times 3 times 12, which would give us choice C. So the associative property, we change parentheses, but we do not change the numbers or their order. All right, so now we have the distributive property. So another property of real numbers combines multiplication with addition or subtraction. To multiply a sum or difference of numbers in parentheses, each number inside of the parentheses is multiplied by the number outside the parentheses. So with the distributive property, we're taking something that looks like this, a multiplied by b plus c, and turning it into something like this, ab plus ac. So in other words, this is how we did it in class towards the beginning of the year. If I take a multiplied by b plus c, right, we make sure that we multiply a times b, which is ab, and then a times c, which is going to be plus ac. So this was one of the sayings where in class you may have heard that Superman saves everybody, right? So a works with b, and then it also goes with c, and this is our simplified answer here. It's the same if we have numbers. So in the next example they kind of showed you here, it said 3 multiplied by 5 plus 9. We work this out the same way. 3 times 5, which we can write 3 times 5, plus 3 times 9. 3 times 9. Then we could go further and simplify this here. 3 times 5, right, it's 45, plus 3 times 9, 27, which when we add together gives us a simplified 71. But in this case, they just wanted to show the distributive property there. So notice here, when we have a minus inside of our parentheses, so the difference here between our minus here and our plus here, it doesn't change the process at all. It doesn't change the process. We still multiply a times b and then a times c. The only thing that changes is that we have to treat this minus here in the middle and leave it there. So again, the example, if they use 2 multiplied by 6 minus 3, again 2 times 6 first, then minus 2 times 3. Also, it says here to be careful when the number outside the parentheses is negative. We have to treat that and remember that that stays with that number. So if we have over here negative 4 times y plus 2, we have to make sure we're multiplying negative 4 by each term. So negative 4 times y, then negative 4 times a positive 2, and that works out to be negative 4y, and then negative 4 times positive 2 is negative 8. Now the trickiest part, and usually where this leads to mistakes, is when we multiply a negative by a negative, which happens in this next problem here. So here we multiply negative 2 times x, which gives us negative 2x, but then we multiply negative 2 times negative 5, and we remember that negative times a negative is a positive, which gives us positive 10. So if we take a look at the example below, the sample question that they have, right, it says, which expression has the same value as negative 4 multiplied by 7 minus 3? And we would go through and make sure that if we take a look at our answer choices, there are 2 choices choice C and D, where we did not multiply -4 times each term. So remember that Superman saves everybody, so we can get rid of those two choices. Then if we take a look here, we have -4 times 7, so that is the same in both of these. Then we have -4 times -3. So again, a negative times a negative is going to give us a positive number, so our choice is choice A. So for this next part here, I'm going to write out the example that they have next on page 17, about halfway down. So it says to simplify the expression, and then we have 6 parentheses y plus 3 minus 4 parentheses y plus 2. So in this case, we're going to be using two of the properties that we have talked about so far. We're going to use the distributive property and then the commutative property. So to start with the distributive property, we're going to distribute our 6 to each of the terms inside of the parentheses here. So we're going to have 6 multiplied by, oh, that's not a great marker. Let's see how the blue one works out. 6 multiplied by y gives us 6y, and then 6 multiplied by 3 gives us plus 18. Now again, remembering that when we have a subtraction sign in front, we're actually going to attach it to this 4 here to distribute it to both terms inside of our parentheses. So we'll have -4 times y, which is -4y, and we'll have -4 times 2, which is going to be -8. So at this point, we need to combine like terms. So in order to combine like terms, we first have to identify any terms that have a variable that is the same and also to the same exponent. So here we have 6y, and over here we have a -4y. So those are both like terms because they both have a y and it is only to the power 1. Then our other set of like terms is going to be positive 18 and -8. So when we are combining these like terms, we're going to be adding them together. And so for the first one, we have 6y, and we're adding it with our -4y. So two ways to write this here. You could write it as 6y plus -4y, or if you chose to, you could also write it as 6y minus 4y, and that's how I'm going to keep it here. Then we have our 18 and our -8. So again, we have plus 18. Then we have our -8 here. So now when we combine our like terms, we start with 6y minus 4y. When we're subtracting, we only subtract the coefficients, so we subtract the numbers in front. So 6 minus 4 is 2y. And then a positive 18 minus 8. 18 minus 8 is a positive 10. And this is our simplified expression. So we went from an expression that had, zoom out a little bit here, had the distributive property and many terms, right? And we simplified it down to just a binomial with only 2 terms here, this 2y and this 10. So the next one they said is, which expression is equivalent to, we're going to start at the top here, 4 parentheses 2x plus 4 minus 3 parentheses x minus 5. So again, we're going to start it with the same process of distributing our term that's outside the parentheses with our terms inside. So we multiply 4 times 2x, which is 8x. Then 4 times positive 4, which is a positive 16. Now we continue on the right side with -3. So -3 times x is -3x. And then -3 times -15, we have a negative times a negative and we get positive 15. At this point here, we have to use the commutative property to rearrange our like terms so that we can simplify them here. So again, we are going to simplify, or start to identify, first our like terms of 8x, positive 8x, and negative 3x. And our other set of like terms, which is just our numbers here, positive 16 and positive 15. So we can rearrange them so they're next to each other. So 8x minus 3x plus 16 plus 15. Then we simplify 8x minus 3x, subtract the numbers in front to get 5x. Then 16 plus 15 is plus 31, which would be our simplified answer here. If we look at our choices though, for our multiple choice, they actually take a look and stop us at a step that is up here before we collected like terms. So while we went through and simplified the whole thing, the multiple choice answer will look similar to that choice there, which if we take a look is choice D. So right here, this is choice D for sample question 3. All right, and as we're going through this, if you have any questions or need me to go over something else, please message me on Schoology. At the top, there's a little mail button there that you can use to create a new message, and just go ahead and type whatever questions you have. All right, so now we're going to take a look at a little deeper at algebraic expressions and about factoring out a greatest common factor. So at the top here it says an algebraic expression may have one or more terms. Examples of expressions with only one term are 4x, 4x and 4x squared. So just a reminder over here that when we say the word term, a term is a number, a variable, or the product of numbers or variables. So these are all examples, with 4 being a number, 4x being a product of a number and variable, and same as 4x squared is also a product of a number and variables. So the examples of expressions with two terms are 3y minus 9 and 5n plus 2. So these just have two different pieces to them, separated by an addition or subtraction sign. So an expression may also be the sum or difference of more than one expression, such as 2xy minus yz. So here, again, if you take a look, we do have different variables here. Just another example of an expression. Now, recall that the greatest common factor, or GCF, is used when factoring a set of numbers or expressions with variables. The GCF is the greatest factor that evenly divides into a set of numbers or terms. The GCF can also be used when factoring algebraic expressions. The GCF divides each term. The product of that result and the GCF is a full factored form. To check that an expression is factored correctly, multiply the factored form. The result should be the original expression. So what they want us to do is take out the greatest common factor of the expression that they gave us here. So for this one here, they gave us 40 xy minus 25 xyz minus 50 yz. So, in order to find the greatest common factor, we start by looking at what number is the greatest number that goes into each of these coefficients. So what is the largest number that goes into both 40, 25, and 50? And the way that I would go about this is look at the smallest coefficient. The smallest coefficient is 25. So we want to think about the factors of 25. So if I'm thinking of the factors of 25, right, make a little note up here. We have 1 times 25, and then our only other set of factors is 5 times 5. There are no other numbers that multiply evenly into 25. So at this point, we want to see what is the biggest one of these factors that goes into all three terms. So 25 is the biggest number. So let's see, if does 25 go into each one? So 25 goes into 25 one time, so it works for that one. 25 goes into 50 two times, so it works for that one. But 25 does not go into 40 at all, so we cannot use 25. Then the only number we have left to try here is 5. Does 5 go into 40? Yes, it does. It goes in 8 times. 5 goes into 25, 5 times. And 5 goes into 50, 10 times. So 5 is going to be our greatest common factor. So what that means is that we're going to start by dividing each of these terms by 5. Now we have to address the variables. So in order for a variable to be factored out, each term must have that variable. So our first term has the variables x and y. Our second term also has the variables x and y. Our third term, however, does not have an x and only has a y and a z. So the only variable that they all share is our y. So we're going to now divide by that as well, because that is something that is in all of these terms here. So we divide each term by a greatest common factor of 5y. When we go about writing this next step here, we're going to write 5y on the outside of a set of parentheses, and then fill inside the set of parentheses each term after it was divided by 5y. So, for example, 40 divided by 5 is 8, and then y divided by y, our y's will cancel out, turn into a positive 1, and we'll just be left with the variable x. Then we use our same sign here, so minus. 25 divided by 5 is 5. Again, our y's will cancel out, and we'll be left with x and z. Then again, we bring down our subtraction sign. 50 divided by 5 is 10. Our y's cancel out, and then we're left with z there as well. So this is our factored form. We took out the greatest common factor, and if you're looking at your answer choices there, right, you'll see that choice B is the same as the one that we have written here. All right, the last thing we're going to look at in this lesson is exponents. So I'll go through, read a little bit, and then write a little bit off the side for some notes here. So the first thing says, a number raised to a positive exponent or power n is the same as multiplying that number by itself n times. And then it gave an example of 3 to the 5th power is the same as multiplying 3 5 times. So if we go 3 times 3 times 3 times 3 times 3, it's the same as writing it as 3 to the 5th there. And that equals 243. So if we raise a number, now it starts to talk a little bit about, jumps right into negative exponents. So if we raise a number to a negative exponent, however, we're really saying that this is 1 divided by 2 by 2 by 2. So if we have 2 to the negative 3, right, we start off with 1, and then we divide it by 2 3 times. The other way to think about this here, if we wanted to write it out, is when we have 2 to the negative 1/3, what we do is we put a 1 and then divided by 2 to the positive 3, or 2 to the positive 3rd. So by moving it to the denominator, we turn it into a positive exponent. So a quick example of that there. If we took any example here, if we had 4, or let's say 5 to the negative 6. If if we wanted to rewrite this with positive exponents, we would simply put 1, so this is equal to 1 over 5 to the positive 6. So this just changed here, went down into our denominator, and then it became a positive number. Now, if we had like a variable, so let's say x to the negative third, right? Again, this doesn't change what we do. This is still equal to 1 over x to the third. Now, the only thing where this starts to get tricky is if we have multiple terms in our expression, we only move the terms that have the negative exponent with them to the bottom. So if we had, the parts of the term. So if we had 2x to the negative third, this negative third only belongs to this x. This 2 is its own coefficient out here that doesn't have any exponent that is negative up here. The exponent for our 2 is a 1. So if we wanted to write this with positive exponents, the 2 would not change where it is. So it'd be 2 divided by x to the positive third. So negative exponents can be a little tricky, but the key is you move them to the bottom or the denominator, and then they become positive there. Now, the next thing that it shows us is rules that have to do with multiplying exponential expressions. So when we're multiplying exponential expressions, we add. So multiply, we add the exponents. So an example of that they show over here is that x to the a times x to the b equals x to the a plus b. Now that can be a little confusing, but it's not too bad. So when multiplying exponential expressions, like x to the fourth times x squared, what we do is we add our exponents, so x, and then we say 4 plus 2 is to the sixth. Now this does not change if we are if we have negative exponents either. So if we have x to the negative third multiplied by x to the positive fifth, right, we would say it is x and then negative 3 plus 5 is to the positive 2. So again, whenever you're multiplying exponential expressions, we add the exponents. The next one takes a look at dividing. So here, they say to divide exponential expressions. So when we're dividing, we subtract the exponents. So if we take a look over here, we have x to the a divided by x to the b, which is the same as x to the a minus b. So similar examples here. If we have x to the eighth divided by x to the seventh, we can write this out as x to the 8 minus 7, which is equal to x to the first, which again we can often just write as x because we do not write the exponent there if it is a 1. If we have a slightly more difficult example, let's say we have x to the third divided by x to the sixth. We would have x, then we have 3 minus 6. 3 minus 6 is negative 3, which then we would want to convert to be a positive exponent, so 1 over x to the third. But in the end, all we're doing is subtracting our exponents there. So when we divide exponential functions, we subtract the exponents. The last one that we look at here is if you are raising an exponential expression. So you are raising it to another exponent, right? We multiply the exponents. So raising an exponential expression to a power, we multiply the exponents. So they showed us that over here, that x to the a, all raised to the b, equals x to the ab. So they also showed us that the product of powers can also be raised to a power, and when this happens, each factor in the product is raised to that power. So, for example, if we have 3 multiplied times 7 squared, notice how this is inside of the parentheses. So this to the 4th power is applied to both the 3 and to the 2. So we have 3 times 1, which is 3 to the 4th, times 4 times 2, which makes it 7 to the 8th. So it's attached to both of them there. So when we take a look at that next example there, that says negative 2 to the 3rd, then squared, we write it over here, negative 2 to the 3rd squared. It means that we're applying this 2 to that 3rd there. So since it's being raised, we're multiplying. So we have negative 2, and then 3 times 2 is to the 6th there. Now, when we're saying negative 2 to the 6th, if you're using your calculator, you need to make sure that this negative 2 is inside of parentheses here, because we are saying it is the same as negative 2 times negative 2 6 times negative 2, and negative 2. If you do not put that negative inside of the parentheses there into your calculator, it will just do 2 to the 6th power and then multiply it by negative 1. But if you do put it inside the parentheses here, you'll see that this works out to be 64, which is choice D, positive 64. Now, when you're taking a look at your questions here, go back to some of the examples that we had and do it in multiple steps here. So there's a couple that we can look at. I'll actually just look at this one with you here because it has to do with the exponents. If we were to have a problem like problem 4, so if you look at problem 4 on the problem set, I'm going to do a similar problem. It'll be a little bit different, but it's going to be similar in terms of steps. If we have, say, x to the 8th divided by x to the 3rd, and this is all raised to, let's say, the 2nd power here. If we're able to, we should simplify what's inside of our parentheses first. So if we're dividing this x to the 8th divided by x to the 3rd, we have to remember that when we divide, we subtract. So 8 minus 3 is 5. So now inside of parentheses, I have x to the 5th. Now that is squared. Now when we're raising an expression to a power, we multiply. So we'll have x to the 5 times 2, which is 10. So it might look a little intimidating at first, but break it down into multiple steps and it shouldn't be too bad. The rest of the questions in this problem set are ones that are really similar to ones that we did earlier in this lesson. So again, if you have any questions, make sure that you send a message through Schoology. All right, and other than that, good luck and keep working hard.